Okay. So the first question there, 2 scenarios when a process should be stopped based on analysing consecutive sample means. So it probably should have said it a bit clearly, but really, I mean, we're talking about control charts. Either you have 2 consecutive outside the inner control limits, that's the first one. 2 consecutive samples. Or was it any 2? No, it's 2. Yeah. Samples outside inner control limits. And then the other one is 1 sample outside the outer. Outside outer control limit. Obviously, or worse. Now I think it's probably nearly impossible to have 2 consecutive outside the outers. I won't get into why, but it shouldn't ever happen. Okay. B. Use sample 3 to set up a 95% confidence interval for the population mean. So what I'll do is I'll just go to my formula, and it's down there at the bottom, confidence interval. Now for myself, I'm just going to write it as x bar plus or minus t. That c doesn't mean anything. I might even have gotten rid of it. S over root n. Now you might have sigma here. It probably should be sigma, but sigma is approximately s. So if we just calculate those 4 numbers. Where's this?
Yeah.
Just in here.
Oh yeah, no, sorry, but the question 4, is that a question 4?
Question 4, part
You
B.
give 2 scenarios where a process should be stopped based on analysing consecutive samples.
That's this.
Okay. Well, you've 2, there's 1 sample outside.
So, but it's look for 2 scenarios. So this is the first scenario.
Oh, right, okay, sorry.
Yeah. Okay. Now we need to calculate these numbers. What's x bar represent?
The means of the mean.
Yeah, it's just the mean. So we'll go to sample 3 there. So we're looking at 17.7 plus 15.1 plus 12.3 plus 20.9 divided by 4.
16.5.
Nice one.
Is that the mean or the sample mean?
That is the sample mean, but they have the same. It's so mean and sample mean you won't get confused with because they're the same formula. But the mean is supposed to be all of them, and sample mean is just some of them.
We need to know that formula. That's not written down on the exam.
It is.
Is it?
Yeah. Down the bottom, it's written slightly differently. Look at your statistical formulae on the. So this is it. Have you got your manual?
I have the exam.
Alright. So it's down the bottom of that page. Same as that. So it's just between those 2 numbers. It's easy for me to write a plus and minus. The next one then is the t value. So you go to your t table, and this thing is page 9. I don't know how it looks in the manuals. Oh, there it is. It says page 7 in the manuals. So the idea, the numbers across the top, 20, 10, 5, 2, 1.2, are what's outside. If we've 95% outside, if we've 95% inside, 5 outside. And what will the n minus 1 here be? 3. So what will the value be? 3.182. So the 95% means the 5 outside, and then n is the sample size. So your n minus 1 is 3, so just go across that.
That will always be n minus 1, what we're dealing with anyway. wouldn't it?
Yeah.
Do you know in the class things you had, there was a thing that asked for the frequency and use of the frequency. What is that?
Oh.
That was in one of the examples. I was trying to find it here.
Yeah, we'll see it in a moment. We'll see it in a second.
Oh, yeah.
Yeah. Okay. So the next thing we calculate the s. So there's a formula for the s as well, and I recommend we use the first bit. So you'll see a little thing there. So sample standard deviation S equal to square root. So yeah, so this is where it would be. So those F's, so we'd be saying, oh, you've got how many copies of this, how many copies of this, how many copies of this, how many copies of that. That's like for question 2. But in this, we just have one of each. So all the F's are 1.
One of each box.
So that point.
So like we have 8 samples there, yeah, but we're focusing on sample
Well,
three.
we're just looking at sample 3 now.
But
So
so what's the, is it the frequency between the first
Well,
sample and the second
well,
one?
how many 17.7s do you have?
1.
So the frequency of that is 1. How many
Oh,
15 point? How many of them?
How often does it come up? Or how often?
How many of them? Yeah.
Is
Yeah.
it? That's what it is.
So we're not going to actually use exact. We're not going to write this. We're not going to write the F's because the F's are just equal to 1.
1.
Yeah. So we're going to have add up. I won't. So that's just 1 times x minus x bar. So that's just x minus x bar squared. And if you add up the frequencies, it's just 1 plus 1 plus 1 is 4
yes.
minus 1. So this will be n minus 1. So this doesn't quite appear on your exam paper, but it's pretty much there. It's the same as the first S. The F's are 1. Add up the F's, you just get the number of the sample size, and then there's the minus 1. So this is what we're looking at.
Just go back to the T there.
Yeah, okay.
You went with 5 because it's 95%
Yeah.
final 5, yeah? That always do it.
So if it was a 90, it'd go to the 10.
Sorry. Where'd you get the N is equal to 4 there? Oh, yeah, is that because there's 4 samples?
Yeah.
No, that's how many are in the sample. There's 4.
Yeah, sorry.
Where do you get the T? 3.182.
So you go back to there's a table. Have you got that in front of you?
Yeah.
Page 9.
I think it says page 7 in the notes.
Yeah, run that.
Yeah. So you see the thing down the bottom, the picture.
Yeah.
We're trying to get 90% in the middle, or 95. Sorry. So if there's 95% in the middle, how much in those tails?
2.5.
Each, which would add up to
5%.
5. So you're going to cross the 5 on the top. You have that?
Mhm.
Now what's our n minus 1 here?
3.
3. So go across from 3 to 5, and that's where the 3.1 is. Now if I'm doing it, what am I going to do it with this? Yeah, if it's me here, what I would write is, you don't have to do this, but this would be myself. So these yolks, the difference between the data point and the sample mean are the deviations. So if I'm doing this myself, I do add up deviation squared over n minus 1. It just makes a bit more sense to me, and so that's how far away that is from that, that from that, that from that, that from that. And because I'm going to square them, it doesn't matter if I make them positive. So
Are we given? We're given that first S thing though, we are.
yeah,
But not
it's
the
got
second
F's in
part.
it. So just take the F's out.
Oh yeah, but the S is 1.
So the first deviation is 1.2. The second deviation is 1.4 and then squared. This deviation is 4.2. And this deviation is 4.4.
Yeah, so
Just the difference.
there's minuses, don't
You-
there? Doesn't matter.
If you've minuses, if you square them, now you're in trouble. If you put a minus here into the calculator, like say let's see, 15.1 minus 16.5. If you put a minus there, calculator will be wrong. You're going to get the wrong answer. You'd have to put a bracket around it. Because let me show you now. So if you go into the calculator, minus 2 squared doesn't give you plus 4. It gives you minus 4. It's just the squaring first. So one way of getting
So
around
just
it,
leave the negatives all out, you get us all.
I think you're better off leaving the negatives. You're understanding it better if you leave the negatives
Yeah,
out.
that's
Yeah.
easy.
All over 4 minus 1. Look at this.
40.4.
40.4.
3.65 33 yeah.
What is that?
Oh yeah, 3.669.
And the 9 isn't rounded or anything like that.
Isn't
Yeah, it's
No,
definitely the four significant
Because
figures
I
is
would
good.
have rounded up to 9, yeah.
Yeah, that's spot on, that's correct, yeah. So four significant figures is what we want to see. Okay, so we have all the numbers, so we just bang into this. So we have x bar 16.5 plus or minus 13, sorry, I remember, 3.182, S 3.669, all over 2. So I'll get two numbers, a small one and a big one. The big one. Sorry, I should have written square root of 4 here, which is 2.
Because that's not still part of our S thing, though, was it?
We've calculated S.
S is that, and what's this next part now? That's just moving on to the main sample deviation.
Well, we've calculated all the numbers. X bar
Yeah.
is the sample mean, T we found, N
Yeah.
we found. This is S.
Yeah.
So I'm just putting those, banging those numbers into this,
Into the original equation.
into the
Oh, okay.
format, yeah.
Okay.
And it'll say, comment briefly your, what does this mean? So you're 95% confident that the population mean is in here. So you could, probably the smallest thing you could write is 95% confident. So if you want to write population mean, I'd be happy with mu, or population mean indexed.
A population mean doesn't matter even though we're taking samples of temperature of gas.
So population just means all the data. So what we got here, so we got a certain gas. So it's kind of hard enough to define the population mean here, but if you had the gas from all, absolutely every single instant from when it exists to when it doesn't exist, what's the average temperature in all that possible time? So the population means all the different times. Okay. Any questions on that?
That's that 10.66. That's if you were to use minuses and 22.34 is it when
Yeah.
you use plus.
And what would be your mid? Is 16.5 your mid? And
Yeah, well you won't, I mean,
when you're doing the
it is in the middle.
when you're doing the control.
When you're doing the control chart, well, you're not going to just use sample 3, you're going to use all 8 samples and average them all out. That would be your version of 16.5 there.
And so there's like the question in the exam now, it can't deviate that much from what we done there. So like I might have more samples, I might have.
Well, I mean,
sorry, yeah.
we've a bit more to do obviously, but parts B, that's about all.
Obviously, so if there's 5 samples, your n changes to 5 and your n minus 1
Well,
goes to
careful,
4.
there's, yeah. And then your T would change as well.
Yeah,
Because you'd have to go in, yeah.
What are you saying there in that last part of 95% confident? What's that U in this?
Mu, so this mu is the
Yeah.
population mean. So we just looked at the temperature at 4 different instants. Population being all the average over all possible times. So the true average temperature. So sample refers to some of the data, population refers to all of the data. Okay. So now we will calculate the rest of those things. So probably reasonable maybe just to set up a little table for myself. X bar W. So we got 20.5, 2.5, 21.25, 2.1, 16.5. And then the W is the difference between the biggest and the smallest. So the third one, what's the difference?
8.6.
The third one? 5 points?
8.6.
8.6.
Oh yeah, 8.6. And then next one is there, 19.8, 1.6, We'll just do the ranges anyway, and maybe people in the class have the other ones. So W5, 11.2 to 12.1, sounds like 0.9.
That's 0.9, yeah.
The next range is 10.2 to 21.7, that's 11.5.
Yeah. 8.5 is next.
8.5 is next. 2.9 we have. And we have one more average here, it is 19.25. And I'll take whatever's going after that.
23.95 is number 7.
That's working backward. Well, actually, it doesn't matter. So what was it, 23?
595, 17.5 is 6, and 11.65 is 5.
Let's calculate the remaining means. And sample means find the grand mean and the associated inner and outer control limits, and then set up the control chart. So I'm going to do the control chart actually on the whiteboard without a scale to show you how you can. I only care where they fall, not that they're plotted perfectly.
So we don't have to do all the values in the exam, just draw the lines and show, show the points relative to it.
Well, yeah, the relativeness is the important thing. So I'll do something on this that will be good.
Doesn't have to be scaled.
Doesn't have to be scale. And like even if you, well, the thing is if you, so yeah, it doesn't have to be scale. Now it should be symmetric, because you want to understand that they are equally above and below. How do we get the x bar?
And up all the average mean.
Add up, get the average of all these. So the average of the averages is the same as. Don't suppose you have that as well, do you?
18.8.
That's great. Do nothing. Okay, so that's the grand mean. Now we've got so try and give you as many formulas as possible, but this one we're not giving you. So so there's a formula then for the various limits. So it's like this one, and it's supposed to mirror these. So you're going to have, instead of the x bar, you're going to have the x bar, and then the a is like the t, so it's kind of a statistic. It gets bigger as the confidence gets bigger, etc. So this, instead of the t, you have the a values. Now there's two a values, but we'll worry about that in a second. And then this is roughly how spread out the data is. So you use the w for that.
If we used x bar there instead of x bar there, would you lose a lot
Do you think I know? No.
Because, yeah, something.
But the x bar, is that the average of all the
Averages,
is it?
yeah. Which is the same as if you just, there's 32 data points. If you found the average of all, then you get the same thing. Yeah. We may as well find w bar while we're here.
4.8.
4.82. Great. Okay. So we're going to have to calculate two sets of pairs of limits. We'll have to get a values. We'll do that now in a second.
That going green, that's not in the tables.
No, not in the tables. But it's like this yoke. Both got the x bar, both got a statistic from a table, measure of spread, measure of spread. So we may as well, while we're here, get the a value. So there's an a, well actually it's a dashed I think in the thing. So 0.001 and a dashed 0.05 or 25 is it? Now what that signifies is 2.5 in each tail, 5% in the tails, 95% in the middle. So this is like a 95% confidence interval, and this is like a 99.8% confidence interval. So you go to your A table.
What other examples would you think they could be asked for?
Yeah.
Instead of 95%, could you ask for 98 or 90?
Can't be, there's no other A values,
Right.
so can't ask you anything else on these. On the other one, yeah, it could be, it'll have to, the only option, on 80 isn't popular. 90 isn't popular. 95, 98, 99, 99.8.
They're the 4.
They're the 4. I'd probably 95 is. No, I better. No,
That's not it.
no, careful, because it mightn't be. I'm just saying that that's the kind of standard one. You know, it mightn't be though. So don't quote me on that. Even though it's on the video, don't. It's not legal. Actually, there's no A dashes on these. It doesn't matter. So you go to the sample size. What's the sample size here? 4. 4 again. So the first one, or the 0.025 under 4 is 0.476.
What table is that, sorry?
I don't know. It's 6.
Is A dash always 0.001 and then 0.0?
No, this is, so if you look at the tables, they're there. Control chart coefficients. So look, it's not copied very well. That's 001, that's 025.
They're always
Always those two, yeah. And then the other one is 0.75. Yeah.